Okay, thanks, and thanks very much for inviting me. It's great to be presenting at events like this. I normally only present to computer scientists, so this makes something of a change for me. The focus of my talk is going to be on emerging digital technologies. I should say from the outset that I'm not a philosopher, I'm a computer scientist, so this is going to be a very technocentric talk. I'm not going to even attempt to masquerade as a philosopher. I'm going to talk about my experience of developing technologies, particularly knowledge-based systems, and also provide at least a cursory overview of where I think we are in terms of the current state of the art, in terms of emerging digital technologies and their potential impact on human cognitive capabilities. So just to give you some idea of where I'm coming from here, this slide highlights some of my current areas of research interest. Most of my research at the present time is geared towards virtual environments, developing simulation capabilities using game engines. And I have a collaborative link with Carnegie Mellon. I also work and have worked very closely with IBM over the last 10 years, where the focus has been on developing capabilities to support human-machine interaction and also the development of cognitive systems, particularly hybrid systems involving both elements of machine processing as well as human activity. Most of my kind of applied engineering work is in the defense realm, so I work very closely with the US Army Research Laboratory and the UK Ministry of Defence looking at issues in intelligence analysis, and I also work with Airbus looking at topics in quality of information. And these two areas, I'll pick up on those when it comes to talking about extended knowledge. In particular, I'll talk about some of the ways in which we approach issues such as information reliability and the processing of information to get a feel for what's happening in a complex and largely unfriendly information environment. And then finally, I have a collaborative link with the University of Edinburgh, in fact, and the University of Oxford in the form of the Social Machines Initiative. And this is very much geared towards trying to understand the way in which web technologies are changing or influencing the kinds of social environments in which we now live and the kinds of socially distributed capabilities that might be created on the back of web-based systems. So in terms of the talk, I'm going to start by reviewing at least some of the technologies, in particular the ones that I'm most familiar with, and I'll focus specifically on those features of the technology that I think are relevant to discussions of extended cognition. I'll also talk about extended knowledge. I think it's fair to say that my understanding in the area of epistemology is somewhat less than in the philosophy of mind. But nevertheless, what I'm going to attempt to do is talk about these issues of reliability and ability and where I see the interface between philosophical debates and technological innovation. And in terms of the technologies, this is going to be a whirlwind tour through quite a lot of technologies, so I'm not going to cover any of them in detail, but I'm around for the next couple of days, so if people want to talk in more detail about specific technologies, I'm happy to do that. So, technology trends, I mean, really the only thing that you need to know is that there's going to be more of absolutely everything. So in computer science, we have these laws, Moore's law, Gilder's law, Kreider's law. They're all attempts to predict the evolution of computing capabilities, wireless connectivity, bandwidth, and so on. And they all predict largely exponential rates of growth. there's also a superabundance of data. So, I mean, we're all aware of that. But by 2017, the predicted total amount of global traffic, IP traffic, on the web is predicted to be 1.6 zettabytes. And it's always difficult to get a grasp of what these figures mean. But a zettabyte, if my iPod had a capacity of a zettabyte, I could quite happily listen to music for the next 2 billion years without repeating a single track. So it's a lot of data, and it's growing. And of course, when it comes to the web, the invention of the web has been a real game changer for us in terms of technology development. So a lot of the drivers for technological innovation and change now are based around web technologies. But there's also a social aspect to this as well. So the web is not only changing the profile of technology development, it's also affecting the way in which society is structured and the way in which we go about social activities. In fact, I think it's fair to say that there are very few spheres of human activity left where you don't see some involvement of the web. And this is important because the activities that we engage in and the social processes that we see in society are adapting to reflect the ever-present availability of web-based resources and services. And so the situation that we're now in is that the web is a form of critical infrastructure for society. It's something that we can't do without. In fact, in the defense community, there's a general consensus that a coordinated cyber warfare attack on our internet infrastructure would be far worse in terms of the preservation or the functioning of society than would a nuclear strike. Which is kind of ironic when you think that the internet was actually invented to preserve the functioning of society in the face of a nuclear strike. That's the nature of technology development. Every success contains the seeds of its own overthrow. So I'm going to start the tour of technologies by starting with the semantic web. So, I mean, we're all familiar with the web, or at least we think we're familiar with the web. The web, as it's currently constituted today, is in large part intended for human consumption. So we've got images, we've got video, we've got natural language. There's a lot of knowledge out there, there's a lot of information, but much of it's in a form that's not very amenable to machine-based processing. The semantic web is an attempt to try and provide an infrastructure for human knowledge representation on the web in a form that is more amenable to machine-based processing. So the aim is to try and represent human knowledge in a form that machines can understand and manipulate. And on the back of this kind of representational infrastructure, the hope is that we will be able to develop more sophisticated forms of machine-based processing and also assist humans with respect to capabilities such as semantic search. This kind of approach as well is also important in terms of thinking about machine-to-machine communication, how machines exchange information, how they reason with each other, and also in terms of human-machine communication. So one thing that we see in contemporary web science research is an interest in what are called controlled natural languages, so controlled variants of natural language that are specifically designed to support human-machine communication in a kind of conversational style. Now, unfortunately, although we've been working on the semantic web for, I guess, the last 15 years, it still hasn't really achieved its full potential. And I think one reason for that is that we overestimated just how much organizations would be prepared to adopt logically complex formalisms and invest the time and effort and energy in kind of learning about the kind of necessary logics in order to represent information. So what's happened in more recent years is that we've kind of relaxed some of the constraints associated with the semantic web, some of the emphasis on semantic enrichment and formal logic. And what we've moved towards instead is this idea of linked data. So the idea here is that we're still using some of the basic data formats that we saw in the context of the semantic web, but the main goal is to build what you might call a globally distributed database that's built on the backbone of the web, an infrastructure in which we can represent data and, if necessary, apply semantics to it. So that doesn't rule out the use of semantic web technologies. But the main goal is to get data online in a form that's amenable to machine-based processing and develop capabilities with respect to that. And I think when it comes to thinking about extended cognition, extended mind, extended knowledge, there are a lot of advantages that might not be readily apparent in terms of moving towards this more data-oriented representational style. So one of those advantages is that, in contrast to the way in which information is currently represented on the web in the form of web pages and human natural language, representing data items and the linkages between data enables us to implement very advanced forms of information display. We can integrate data, we can present data in a way that's agnostic or relatively agnostic with respect to the kind of device that's being used. So it enables us to move towards something like this kind of real-world overlay that might be provided by something like an augmented reality device. And that's very difficult if you adhere to the kind of formats that we have in the context of the conventional web. So another issue is that our access to the web is typically mediated by, or has been typically mediated by a web browser interface, but of course all that's changing now. We're moving to this era of data-driven apps, where apps do specific things, they're targeted towards the realization of specific capabilities. So in terms of this new generation of apps that might service very specific problem-solving activities, the move towards this linked data format is, I think, very advantageous. Search and query. So the advantage of a global database is that you can execute queries against it and get at the specific information that you're interested in. It's not the same as trying to access information from Wikipedia. So if I want to find something out, I go on the web. First of all, I do a Google search. I get the Wikipedia page. Fortunately, Wikipedia doesn't have all of these adverts that confuse and disorient me, but nevertheless, I still need to scroll through the page and do some reading. And so there's a big time delay there. My access to relevant information is impeded by the way in which information is currently represented on the web. And so I think this move towards a more kind of data-centric representation has great benefits in terms of thinking about the kind of access that might be required for the realization of extended minds. Another factor of interest here is device independence. So if I'm accessing data on an iPhone and then I go out, I leave the iPhone behind. So that resource is not as available as it should be in terms of supporting or scaffolding my cognitive processes. But I might have a plethora of other devices that I still have available to me, like Google Glass or an iWatch or whatever. The advantage of linked data formats in this case is that it doesn't really matter what the device is. You can present the same body of information via different devices. There may be different presentational styles, they may be tailored to the kind of specific task in which individuals are engaged, but the point is it provides us with a much more available, it provides us with much more reliable access to information than what we might have if we relied on a single device. And then finally, there's this issue of digital obsolescence. So a big concern in the computer science community is we're putting all of this information online, much of it's in the form of images and video. Those formats can go out of date. Maybe not this decade, but in 20 years, who knows? If a lot of your dispositional beliefs, let's say, are bound up with that format, suddenly those formats become obsolete. All of that data is lost, or at least it's very hard to get back. So one advantage of linked data in this sense is it's using kind of ASCII-based formats, very primitive ways of representing data that are much more robust in the face of issues regarding obsolescence. So one advantage to putting data online is that it's not just available to you in different situations and locations, it's also amenable to online processing. So you can have online services that are doing various forms of data management, data sanitization, data tagging, and so on. And I think that this is particularly important. It's something that Robert Klaus alluded to as autonomy. It enables machines to do some of the kind of data management tasks that otherwise we might have to do, especially if we're exercising epistemic hygiene. But one issue one thing that's typically overlooked in these contexts is the data that you put online doesn't need to be shared by everyone. You can have very personalized data sets put online. So in my own case, for example, I have a personal data store in which I try to put everything that's relevant to my scientific and intellectual activities. It's semantically enriched, so I can execute semantic queries against it. I can get at just the information I need, and it's very much tailored towards my idiosyncratic needs and objectives. So when we talk about cloud computing, I think that's something important to bear in mind. There's no reason why we can't personalize data online and limit access to it. Typically in extended mind debates, we talk about the mind extending outwards. I think the current interest in wearable technologies and the way in which they're being used reminds us that technologies are also encroaching in on us. I think many of these devices are important when it comes to thinking about various forms of cognitive and corporeal extension. In general, I think they enhance our access to information, in some cases entirely new bodies of information. So in the context of work with the US DoD, for example, I know that they're very interested in night vision contact lenses. That's kind of opening up a new kind of access to the world that we have seen before. Of course, we've had night vision capabilities, but not in a way that's kind of as mobile and as portable as contact lens devices are. A lot of these devices as well, and I think this is quite important, they've opened up the possibility of using human or biological resources and putting that to useful computational work. So there's now this kind of emergence of subconscious computing and drawing on the kinds of physiological and, in the case of brain-machine interface, neurological responses that we have in the environment and using that to facilitate forms of information processing that are otherwise difficult. I know Microsoft, for example, are interested in using this to support face recognition capabilities. So typically, in the past, I've tended to talk about Google Glass in the context of wearable technologies, and that seems somewhat inappropriate now because it's gone back to the lab for a bit of a refit. So what I thought I'd do instead is look at Microsoft's offering in this space. Now this I've got a video, this may not work. It will at least challenge the, so prototypes of that device are currently available to the development community. The commercial release date is scheduled for December 2015, so later this year. Of course, your experiences may not correspond to Microsoft's, but just warn you. So one point that I think it's worth making in this kind of context is when we think of wearable technologies and the way in which they might extend our minds and bodies, I think something important is missing, which is that these kinds of capabilities, Google Glass, Microsoft HoloLens, they potentially at least enable us to think about ways in which the physical environment itself is transformed or extended or augmented. So we have this notion of extended environments, kind of augmenting the physical environment in a way that ameliorates cognition. And in as much as we want to think of cognitive achievements as being grounded in episodes of real-world perceptual processing, I think the advent of these kinds of technologies over the next few years is going to open a whole range of opportunities to think about new kinds of extended cognitive systems. I also want to mention this kind of notion of virtual designer environments, which builds on Andy's notion of designer environments. So a lot of the work I do is with purely virtual as opposed to augmented reality environments. But even here, we see opportunities to create environments that we can interact with. Those environments may not even be physically feasible or physically possible. And in addition to kind of enabling new forms of agent-world interaction, we can also use these kinds of capabilities to implement new forms of human-machine interaction using intelligent virtual agents. So we think we know pretty much where we are now in terms of what the web is and what its capabilities are. The question that people are asking at the moment is, what next? What do we do next? Where do we go from here? And so the main focus of interest of a lot of technology companies, Google and IBM being the prime examples, is this kind of notion of cognitive computing. So we know that there's a lot of information and knowledge out there, and it seems like we might be able to do wonderful things with it. But there's so much data, and a lot of it's still very much kind of tied up in natural language formats, that it's very difficult to analyze, and it requires advanced capabilities in order to do that. So there's a lot of interest in trying to emulate at least some kinds of human cognitive capabilities in order to process and make sense of this data and exploit it. And although, for the most part, conventional AI technologies are being used, the kind of gold rush for cognitive computing solutions is really kind of leading to new state-of-the-art advances in technology. So IBM, for example, are working on neuromimetic technologies, so kind of brain-on-a-chip devices. Those are already available. We also have capabilities like DeepMind. So for those of you who don't know DeepMind, it's an organization that specializes in the exploitation of prediction error algorithms to do intelligent things. And Google bought that company recently for $400 million. So they clearly see a lot of potential in using that capability to support their cognitive computing agenda. But in many cases, when we look at kind of cognitive computing solutions, we're not so much focused on kind of capabilities that are solely machine-based. We're also very much interested in cognitive systems, hybrid systems that combine machine-based capabilities with human-based capabilities. And I know that that's very much the focus of IBM in this space. So I'm very pleased that kind of IBM are working in this area, not least because I've spent the last 10 years championing the idea of extended cognitive systems and extended minds to them. And in fact, they've been very, very receptive to the idea. And we're working very closely at the moment, kind of looking at ways in which we might kind of try to take these ideas forward to deliver enhanced capabilities. I want to kind of give you a flavour of the kinds of capabilities I'm talking about. I'm going to show a video of IBM Watson, which you may all be familiar with, but I think it's worth just kind of reminding us what the capabilities are. So this is a video from the Jeopardy quiz game that IBM Watson participated in, and the kind of litmus test of the solution was to determine the extent to which Watson could compete with human subjects in the domain of general knowledge, question-answer capabilities. Okay, so we've seen enough. I mean, so some of so Watson doesn't kind of always perform well, and when it gets things wrong, it gets them spectacularly wrong. But nevertheless, it's a compelling demonstration of what you can do when you've got a large body of information. So all of Watson's knowledge, all of that capability is being driven from information it's sourced from the web. There's obviously a lot of natural language processing that's gone into that in terms of understanding questions, answering questions, processing natural language data. There's a lot of kind of reasoning. There's the exploitation of semantic technology. So it's kind of all that good stuff that I was talking about at the beginning. But the important thing is that Watson is able to do what it does by virtue of the things that we have given it. So all of that kind of content out there on the web, that's all human generated, or at least most of it is. And I think this opens up an interesting debate. It's the debate about to what extent we can exploit human-based capabilities in the context of the web. So the fact that the web is now so ubiquitous, the fact that it's interpenetrated every sphere of human activity, some people might say infected, that gives us a very powerful mechanism now for beginning to tap into human capabilities. And we see that, or the beginnings of that, evident in citizen science projects and human computation capabilities, where human subjects are being recruited to do the kind of work that machines can't do. Although in many cases, I mean, when you look at Galaxy Zoo, for example, they don't really need the human subjects anymore, because the human subjects have contributed so much data that their machine learning algorithms benefit from that and are now able to do the task themselves. So in this context, what I wanted to suggest, and this is probably going to raise everyone's hackles, but in addition to this kind of notion of technology extended human cognition, I think these kinds of capabilities and opportunities enable us to think about the possibility of us, human subjects, society, becoming a resource that is incorporated into the capabilities of the next generation of intelligent machines. So we have this kind of notion of human extended machine cognition. So where does all this leave us in terms of web extended minds? So I think the overall profile of technology development, I think, is largely favorable to the possibility of extended cognitive systems, extended minds. I think certainly when we look at the kind of criteria that are in the literature that seem to govern our intuitions about when we confront an extended cognitive systems, I can see technologies being relevant to at least some of these. And I know I haven't talked about individualization, but that's obviously a key focus for a lot of technology companies. Google are developing these modular phones that enable you to kind of build your own phone-based capabilities and so on. But in spite of the kind of plethora of criteria, I tend to think that the first three are still the most important. And I'm running out of time, so I kind of won't go into detail, but we can certainly talk about that later on. I think, in fact, that from the perspective of technology design, we can pretty much boil it down to accessibility. And that's because, I mean, even if you have a resource and the resource is available, if it doesn't make information available in a form that's suitably poised to guide human thought and action in the right way, it doesn't matter. If you have got access to information, then some form of technological scaffolding is already going to be in place to enable that. So I think when it comes to kind of thinking about issues of technology design, accessibility is at the forefront of our thinking. So extended knowledge. Now I just want to emphasize I'm not an epistemologist. I have made a Herculean effort, I would say, to kind of get to grips with the literature over the last couple of weeks. I focused specifically on process reliabilism and virtue reliabilism. In terms of kind of advancing philosophical debate, I'm really not sure how much progress I can make, but I think the best that I can really do is kind of talk from my own practical experience, talk about issues that are raised by technology, specifically in respect to ability and reliability, and hopefully that will kind of help to stimulate the debate along in productive ways. I mean, one thing that I did want to kind of make explicit at the outset is that I think the kind of notions of extended minds, extended knowledge, it seems perfectly plausible to me that we can have extended minds even if we don't have extended knowers. So the fact that I could have an extended realization base for my set of beliefs, but all those beliefs are false, so I don't know anything. So the possibility of extended knowers, or the impossibility of that, doesn't seem to kind of undermine the possibility of having extended minds. So reliability seems to be central to both these notions of process reliabilism and virtue reliabilism. When we're looking at these things from a technological perspective, we typically tend to focus on, or we kind of break down reliability into two things. So one, kind of functional status. Is it working? Is it working properly? And then also precision accuracy. So how reliable is the information that the device is actually delivering? How accurate is that? And although it may not be obvious, a lot of design efforts are kind of intended to provide clues as to what the functional status of a device is. So this clock, for example, if it wasn't working, if it had stopped, the second hand wouldn't be moving. So the fact that the second hand is moving at least kind of enables me to know that it is doing something, it hasn't stopped. Also, when we think of kind of digital technologies, they have this kind of delightful property that if something goes wrong, if one component fails, the whole thing collapses. Kind of although this kind of brittleness has been bemoaned by many, I think it actually, from an epistemic perspective, may actually turn out to be something of a virtue. It's something to be countenanced rather than condemned, because it kind of gives you some information about what the device is doing. In terms of kind of pure information reliability, a lot of our research efforts in this space are geared towards multi-source information integration. So we're not kind of relying on a single source of information. We're attempting to rely on multiple sensors or multiple individuals as independent sensors, independent individuals, and then combining that information in particular ways. And I think, although a lot of this kind of work is formulated in the context of sensor networks, there's also a sense in which when we're kind of evaluating reliability, we do kind of rely on multiple channels. So sometimes we're kind of trying to confirm or evaluate information provided by a technological device with respect to our own kind of biological sensors. If we had a thermometer here and it reads -10, I kind of know by virtue of my independent sensing capabilities that something's gone awry, either the temperature's wrong or I'm in need of medical attention. So, I think that's important to remember. I've worked on numerous systems now where issues of reliability have been of paramount significance, and there are different kind of approaches that you can adopt in terms of how you support the process by which the information itself or the reliability of information is assessed. So one possibility is you just let the machine does all the work, the machine kind of works out certainty and it just presents the answers to the end user. And in that situation, which, I mean, we never really use, the user often complains, well, I'm not in the loop. So they use this phrase, I'm not in the loop. So they don't tend to like that. So the other alternative is the human does all the work. So we just give them all the data, zettabytes of it. And then, of course, the complaint is, well, there's too much data, I can't do anything. So another possibility is you have the machine do the processing, and then it provides some sort of rationale to the human in a kind of natural language format. Two problems with that. The first is if you're kind of using neural networks or subsymbolic processes to do the sensor integration, it's kind of very hard to get at what the rationale is. Another problem is you kind of generate reams and reams and reams of data that, again, the user complains they don't have time to read. Another strategy is you can kind of provide simple cues and prompts, affordances as to what the reliability of information is. Sometimes, not very often I have to say, you get this kind of complaint, well, I don't know what that means, what does that mean? And then you can also have this situation where human and machines work together in order to kind of resolve the reliability of information. And then you get this complaint, shouldn't the machine be doing this? So, you think as philosophers your life is hard, but it's very difficult being a system engineer as well. I mean, I'm kind of being a little bit unfair here because in general, I mean, these three strategies all tend to be used, and these two in particular tend to be the most useful. So I'm aware that I'm coming to the end of my temporal budget. In terms of ability, so I have a lot of experience of seeing what I think is a compelling example of multiple people working together as a team, trying to kind of deal with a hostile information environment, trying to make sense of it. And that is intelligence analysis. And I think there are a number of points that are worth emphasizing here. So one is that when intelligence analysts are working the problem, what they're often doing is they're deliberately opening up additional channels of information. So, even if they don't have access to multiple sensors, they're using the information they get to then kind of stress test initial ideas. They're kind of providing opportunities for initial body of information to be, I guess you would say, defeated in philosophy, or to be negated in various ways. Another feature is that situation awareness is critical. And so note the emphasis on situation. It's not about isolated facts. It's about kind of trying to understand the environment in which facts are situated. I mean, this is often important because sometimes you can only tell whether one fact is true if you know a lot about a whole host of other facts. So there's this kind of, with situation awareness, there's kind of this effort to build a network of beliefs that then guides or places constraints on the extent to which other kinds of beliefs can be, or other kind of information can be acceptable or not. It's also important in terms of generating expectancies or predictions about how a situation might unfold. Another thing that's critical is a recognition of what you don't know. So it's not just about focusing on whatever information's in front of you. There's also an effort to try and understand, what information do I not have? And of course, that's very important in hostile information environments because a lot of the information is hidden from you, deliberately so. Social interactions often play an important role in terms of, one, checking the consistency of information. It's kind of building redundancy into the sense-making process, but also kind of guiding the way in which analysts go about their activities. So there's this kind of socially mediated scaffolding of what you might say is kind of epistemic good practice. And that's also reflected in technologies. So a lot of the systems I work with, they have monitoring capabilities that are monitoring what the user is doing. And built into them is this capability to try and guide the analyst in ways that might best deliver a positive cognitive outcome or yield cognitive success. So where does that leave us in terms of the possibility of web-extended knowers? So all the technologies that I was talking about there, some of them do rely on the web, but the technologies in general are kind of very much specifically geared to a particular task. When it comes to the kind of the ecology of the web, we can clearly ask to what extent does the web form part of the machinery that realizes belief-forming processes? And I think this is actually quite problematic. I mean, the first problem that arises is, what do we mean by the web? Because I've already talked in this presentation about different views of the web, different visions of the web, different ways in which web information can be presented, different kinds of web-enabled devices. What is the web at root? What do we mean by that? There's also this kind of issue that the rate of change in this space tends to be so rapid that it raises questions about whether we really have time to adapt our own kind of processing routines to the technologies that are available. Are those technologies ever sufficiently stable for them to become candidates for cognitive incorporation? It's also important to note that the web provides what I've glossed as a cognitive ecology, and we've never seen the like of it before in our evolutionary history. It's something entirely novel. So there is a question there about the extent to which our existing biologically based capabilities are really suited to this kind of domain. Are they, for example, suited to the kind of reliability judgment mechanisms that we have available to us? And of course, the web provides a whole host of new opportunities that, for deception and manipulation. It kind of really makes us vulnerable in potentially new and dangerous ways. In terms of kind of moving forward, in terms of future research, I think a lot more needs to be done looking at the kind of context in which information is presented, looking at the possibility of having, for example, reliability relevant affordances, cues or signals that provide information about the source of the information, factors that might kind of be of predictive significance to its reliability, and also looking at how the social environment might be used as a means of ensuring good epistemic practice. So in conclusion, what I've suggested is that when we look at the current state of the art in technology development, I think the overall profile is largely consistent with what we would expect of cognitive systems. There seems to be a kind of technological substrate there that's poised to enable web-extended cognitive systems to emerge. I talked about a few new concepts, not all of them of which may survive, but there they are anyway. And then in terms of extended knowledge, I talked about the way in which, the kind of practical way in which technologies are used in a specific task context. It seems entirely plausible to me that we could encounter technology extended knowers. I guess one of the nagging worries that I have when I read the literature is that a lot of the kind of capabilities that seem to be relevant for establishing positive epistemic status still seem to be in the head. The kind of sensitivity that we have to reliability cues, for example, that still seems to be internally situated. Perhaps one antidote to that is to kind of recognize the way in which social and technological environment potentially shapes or scaffolds our epistemic practices, and perhaps that enables us to think of the possibility of extended forms of epistemic virtue. I'll finish there.